Alright guys, today we'll be talking about the canals on Mars and whether or not they were formed by lava activity or water activity, as well as comparing them to Earth's and seeing how similar and different they are. Alright, first things first, we will be talking about the space missions that are currently going on around the planet, as well as the various data, information, and graphics we have taken from the rovers and space stations that are there. First one up is the MER, or Mars Exploration Rover Opportunity, which is designed to look for past signs of life on Mars, as well as the potential of liquid water that is still on the planet. And since its departure, it is currently discovered that Mars used to have an abundance of liquid water in the past. Alright, next one up is the Mars Odyssey, which has been sent down to collect data on Mars's climate and geology. And also, since its departure, it has discovered hydrogen on the planet, as well as a theory that there's hydrogen in the ice cores on Mars. Now we have gotten to the MRO, or the Mars Reconnaissance Orbiter, which has been designed to analyze the atmosphere and terrain of Mars. Now then, since its departure, it has sent back many detailed pictures of the planet, as well as gone in depth into the history of water flow on Mars. Now we've gotten to the MSL, or the Mars Science Laboratory Curiosity Rover, which has been designed to examine the various craters on Mars. Since its departure, it has been used to determine whether or not Mars is fit to be inhabitable by microbial life, which to this day has been unsuccessful, as even now many researchers and scientists are still unsure as to whether or not Mars can be inhabited by any form of life. Next up is the InSight Lander, which is being used to determine how Mars has changed and also how it is changing. It is also used to explore the inner space of Mars, which includes its crust, its mantle, and its core. Finally, we have gotten to the MARCO, or as I like to call it, the MARCO, which is the Mars Cube 1. Now then, this acts as a communications relay center for both NASA and the rovers. And although it seems relatively small, it is also very vital to the mission, as it is also used among the rovers to send detailed information and data back from one to another in order to help each other with their own research. Alright, now we'll be transitioning into our science class lab experiment. During these clips, you'll see our detailed analysis on how we believe the canals on Mars were formed, as well as you will see us give very detailed information to support our claims, as well as you'll see us tie in how we believe water and volcanic activity come into play into these canals. So right now we're going to start pouring water on this thing to see how the canals on Mars were formed.
That is what diatomaceous earth is. And we know for sure.
So as we can see, the water being poured onto our little model is making dents and making streaks that go through the surface.
So right now, because the surface of Mars,
as we can tell, it's starting to flow through and sink into the water. So there is evidence that Mars currently is absorbing the water. And as we can tell, the more we pour on, the more it just seeps in. But if you zoom in closely enough, you'll be able to see the evidence of like wet gravel, wet sand along the surface. Now then, we're going to do some more. Pick it up. Pick it up.
And
you see the
cracks?
Yep, so as you can see, the more erosion and things that happen on Mars, the more cracks we're going to be able to see from where the water was. So this could explain the designs and the rather cracked design that goes along the Mars surface. Alright? Leia, come over here and help Jesse tilt it to like diagonal.
It's gonna flood.
Go
Just
ahead.
like it would flood here when it hasn't rained for a long time, because the ground would have to soften up.
Alright.
Right here doesn't go through it.
Okay?
Alright, so it's
See
making
how
more...
it goes into it right there?
Okay, so it's making more curved lines
It
there.
doesn't go.
Alright, now let me see what's going to happen if we pour straight down, like that.
That's a lot of water. That's crazy. Okay, but what if it?
Well, we might be able to on some planets. Well, no, there may be planets and other.
It doesn't go through it though.
Yeah, it doesn't go through. All it really does is go down, and the surface of Mars just absorbs it in. I guess it might store it in aquifers if all this water is going down and away from the sun. So there's potential for aquifers or ice caps to be underneath the surface of Mars. So let's try again.
much water.
All right, now that's more like a streak. All right.
Oh, maybe we should just.
So I think from this model, we're able to tell that areas with this sort of pattern on the surface of Mars are more likely to have been wet long ago. You can tell the closer you zoom in, you have the streaks, the canals being formed along the surface. And then in areas where it is particularly wet, you got different colored gravel, and you have cracks along where it was been broken.
If you move the planet
Yeah.
in the surface, it cracks, and that's where you get your canyons.
And then we can also make the assumption that this can be done by air.
And then the more water, the deeper it goes.
Yep, we can also make the assumption this is done by the air and dust storms that go along Mars.
What about the edges?
The edges, let's see what happens along the edges. Let's see.
It dissolves all that stuff on the edge, but whatever that is. Baking soda maybe.
Pretty sure that's just baking soda. So all it really did along the edges was make the edges more cracked as well. A little indent, so
it dries
maybe,
up very quickly.
Yeah, so that's proof that the water just seeps in. And if we touch the model, we're able to tell that the topsoil is still relatively wet. So the soil on Mars can either dissolve very quickly, or maybe it's even sinking through. And we might have polar caps underneath the surface. Well, not polar caps, ice caps.
Or if it's cold enough.
Yeah, or if we dig deep enough, maybe some aquifers down there. But for the most part, we can tell that places on Mars with this pattern.
Let's see if we spread the rocks out more.
Yeah, maybe that's just it. Let's see. Let's see if anything changes when we move around the rocks. Leia, go ahead.
Leia, spread the water.
Try pouring in that. Yeah, try pouring areas without as many rocks. So we're just like get them out of your way.
It automatically seeps in, and look at the color. The color. Look at this color and look at that color.
All right, the
See,
color.
like if you pour it with the rocks, it turns that lighter color, right? But if you don't, it's.
All right, let's make the little divot. Donnella, come here. Bring it a little bit closer. Now we're just gonna show you how fast exactly the water just seeps through.
Boom.
I like
but
that.
look at
It's
that.
gone.
But it made a thingy.
Yep, but it made a little indent. So we can assume that some places like this where there's some sort of crater, not necessarily made from an outside object, but from water itself, we can assume that that's where water has started to seep in.
Little cavern. Alright.
I mean, I don't know. This is all not to scale, obviously, but let's see what happens along the rocks.
Right here.
Alright, let's tilt this up a little bit. Alright, Jesse, pour some water while I tilt. Leia, you're gonna help me tilt. Actually,
Oh, you want me to?
Yeah, let Leia pour. Let her do the honors.
Oh, wait, don't crack it in her.
Alright.
See, let's see why it rotates, you know?
Yep, sure. Alright, so all this has done is really just created more wet topsoil, and as you can tell,
Over
the
time,
gravel.
it'll split.
Yep. So assuming that Mars does have tectonic plates, we can assume that as they move along, the ground starts getting more cracked along where the water was. And let's see. Maybe from the dust storms we can assume that the topsoil also continues to crack. And yeah, that's our conclusion.
So, as you can see, throughout our experiment, we tried putting water at all different angles with different types of obstacles on what would be the surface of Mars in this scenario. We got the same exact result with water all across the board with different angles, different obstacles, and things like that. And that conclusion, that basically results of the water being on the surface is that it forms these channels and these canals and these little indents in the ground where the water was poured or the water went, if it could go anywhere. So sometimes the rocks that we had put into our experiment were blocking the water's path flowing downwards, and it would just soak into the ground and make possible aquifers. We would see that the water would just, enough of it too, would make a deep channel, a deep kind of path into the ground, into the topsoil, which supports the theory that water was the source of the canals and the channels on Mars's surface. So that is what you're seeing all throughout the video when we pour the water, is that supporting evidence to the theory that water is what formed the channels on Mars.
Alright, now right here we have something that is supposed to be around the same consistency as lava. So this will act as our lava for the model. We're going to have Leia come over. Leia, come here. We got Donella behind the camera, so say hi to Donella when you see her. There you go. Alright, so right now we're gonna pour a little bit at a time. We're gonna see what happens if we pour it in like this so we can get like a canal. Alright?
It doesn't seem to make...
It doesn't seem to seep through at all.
It sticks actually and dries into the dirt. It doesn't go in. It doesn't seep in. It like...
Hold on. So let's bring this closer to where we poured this
You
in.
can see that it's on top of the dirt.
Yep, so
Right
all
here.
this area right around here, all this area around where I'm going with my spoon, that was where we poured our so-called
Let's see what
lava model.
happens if it goes just flat.
Yeah, so far we can see that all the lava really does is add on to the topsoil. However, it does seem to morph in with the rest of the
There's,
surface.
like, no
So
rocks there,
There
though.
is clear evidence that. So let's see what happens when we pour it on top of the rock. So add a little bit more, just a little bit. Alright, so some does seem to stick onto the rock. The rest that poured onto the soil around it just didn't seep through at all. Molded in, just molded into where
Ooh, but
the gravel was. So more like a metamorphic rock, actually igneous rock. More
Let's
like
see what
igneous.
happens when you pour water on top of the lava, though.
Alright, let's see what happens when we pour water. Okay, so
Look at
as
that,
we
it seeps through.
Alright, so as we can see, the water just seems to seep through where it touched the lava. Sort of broke apart the lava a little bit. However, parts that were untouched by the water still seem to be there, just in more corroded places. So let's see what happens when we pour water over the cracks lava. Let's see what happens when we pour the lava model over the cracks and stuff that were made by the water. So,
Where's the spoon? Where's the spoon?
alright, so right here. Yep, go ahead and mix up that. But right along here, where I just poured along the cracks, you can see that the lava has seemed to make like a makeshift stitch for that. So it's sort of conjoining the cracks together, acting as a patch, drying up, and creating a new substance rock. Alright? Ignore the
Now,
people in the back.
let's
We can see
see-
Donnella's getting ignored by them.
Let's put a little bit more, and then after that, we're gonna try a large amount at one time.
Alright, so we're gonna try one more little spot, maybe along the cracks right here.
Let's
So
go at a tilt. because
at a tilt along the cracks. Alright,
Yeah,
tilt
you guys
along the
not
cracks
spill
right
it?
around here so we can get some of the rock and the soil.
Oh, that's not gonna go the right way, but it did go at a diagonal down angle, and you see it started to go.
Yep, so we can see right here that not only did it
It's
continue to
just
patch
along
up the
the
cracks
surface.
along the surface, but it also seemed to cover the rocks that were already there. So at this point, it's either morphing into that rock right there or just completely coating it in a new substance.
And then if we just put some water,
Put some water on top of that,
it seems to.
minus the part that got on my lip. It seems to clear up the rest of the rock that was right
Now,
there.
Let's put a massive amount. Well, massive.
All
But let's
right,
put
now would you like to put at it at tilt?
Well, let's just do it flat. Oh,
All right, so
See
we're
what
gonna pour it right here on top of the other rocks. See what happens to the soil around it as well. Leia, you can do the honors. Leia's not doing too much, Jesse. Relax. All right, Leia. Right around this area, please.
just pour a lot of it.
There you go.
Ooh,
Okay,
it's
so the
crazy.
water does, so the lava does seem to go in and fill
It
in the gaps that it can't.
solidifies. I mean, it solidifies on the surface. Let's let it dry for a little bit, I guess.
It does solidify around the surface. It does seem to coat the rocks where it's going, so that's new substance made around the rocks.
It's like a thick. It
Like a-
doesn't seep into anything.
Yep, it's relatively thick. Once it cools, we can assume that this will also become the new topsoil for Mars. Maybe even rocks, depending on how much builds up and how it stacks. And then, let's see, what do you guys want to do with the rest of the stuff we have left? Well, let's pour a little bit more water. So, if water were to come again to Mars,
we can see it doesn't really seep through the lava. The lava, once it at a large amount, it solidifies. And like right here where the rocks are, it seeps through. But on the edges and over here, it didn't really go through it.
Yep, so we can
it's
conclude.
that new topsoil that's thicker.
Yep, and then we can also assume that the water pressure coming from the water coming down is what is corroding the rock and the new lava substance around here.
Similar to Earth as well, right?
Yep.
It turns it into rock, the lava, the different rocks.
Similar to Earth, because we can conclude that the water does seem to corrode along where it was. And then once it corrodes and goes through the lava, some parts of the water do seem to bounce off and just go along where the rest of the soil is so it can seep through. But for those that don't, all it really does is just corrode the rock along where it was and seep through once it's penetrated through the new lava substance.
Now let's see if we pour the rest of the lava.
Now what we're going to do is just drizzle it around the rest of the base.
I was just gonna do a lot, but okay.
But like water erosion,
Alright,
so right now that's not happening.
so far we can conclude that there was a stream based off the amount of evidence left behind. As you can see that this...
topsoil.
Yep.
I mean, that's solid and it dried quickly. I mean, look.
Dried very, very quickly.
And if we pour the water around here, let's see where it's less lava.
Now it completely corrodes where the lava was, thus leaving it more broken up.
So our conclusion is that it's more likely for water to have eroded the topsoil and create the caverns compared to lava. Because lava would have been along the topsoil.
And then this could also be proof that there was water on Mars, because we obviously know that there is volcanic activity as well as magma through the evidence left behind, through, as you can see, all this new paler soil and new substance right there. But if you look closely enough, you'll see the patterns in which the water has corroded it, leaving it to seem more like broken up than the stream we'd normally get.
So it is more likely for water to have made the canyons and craters and things like that and erode the topsoil than it is for lava to.
Yes, and I do believe that there is a chance that some craters could have been created strictly by the lava. However, for those that have evidence left behind, there is a possibility, if they have the right pattern, that water was also the main cause.
Our conclusion to how channels on Mars are formed is by water and water erosion. We based this on the evidence that was found on the missions for Mars. The Mars Exploration Rover Opportunity found evidence of a pre-existence of water for an extended period of time. The Mars Odyssey spacecraft has been studying the climate of Mars and found that a possible occurrence of rain may have happened in the past. In our experiment, we discovered that water would erode the surface and seep into the ground. This would allow aquifers to form and erode the surface. Also, lava was ruled out because it would have formed a new topsoil instead of creating channels on the surface. On Earth, the Grand Canyon is a great example of water erosion and the creation of channels. The water flow over time caused the canyon to grow and become bigger and deeper. On Mars, water should have done something similar, which is why we believe that water is the cause of the channels on Mars.
Now then, this will be the end of our video. Before closing things off, we'd like to give special thanks to our science teacher, Miss Maureen Stover, for providing us with the materials and information needed to create this video and conduct our experiment. We'd also like to give special thanks to the Jet Propulsion Lab and the California Institute of Technology, whose website we were able to use in order to gather accurate data to create this video. This will conclude our video, and my name is Giancarlo Garcia.
This is Jesse Cruz.
And that'll be all.